Dummy items, general or exclusive or formulae seem very complicated, and dealing with them algorithmically would appear to be quite difficult. Luckily, this is not the case, and a generalization of the language makes things simple again. The main idea is to allow exclusive ORs to be represented by ORs. This is done by allowing the bidders to introduce dummy items into the bids. These items will have no intrinsic value to any of the participants, but they will be indirectly used to express exclusive OR constraints. The idea is that an exclusive OR bid, S1P1 exclusive OR S2P2, can be represented as S1 union set D P1 or S2 union set D P2, where D is a dummy item. Formally, we let each bidder I have its own set of dummy items, DI, which only he can bid on. An OR star bid by bidder I is an OR bid on the augmented set of items M union DI. The value that an OR star bid gives to a bundle S, which is a subset equals to M, is the value given by the OR bid to S union DI. Thus, for example, for the set of items M, which is the set ABC, the OR star bid, the set AT1, or the set BT1, or the set C1, where D is a dummy item, is equivalent to the set A1 exclusive or the set B1 or the set C1. An equivalent but more appealing user interface is to let bidders report a set of atomic bids together with constraints that signify which bids are mutually exclusive. Each constraint can then be converted into a dummy item that is added to the conflicting atomic bids. Despite its apparent simplicity, this language can simulate general or exclusive or formulae. Theorem 11.21. Any valuation that can be represented by or exclusive or formula of size S can be represented by OR star bids of size S using at most S squared dummy items. Proof. We prove by induction on the formula structure that a formula of size S can be represented by an OR star bid with S atomic bids. We then show that each atomic bid in the final resulting OR star bid can be modified as to not to include more than S dummy items in it. Induction. The basis of the induction is an atomic bid, which is clearly an OR star bid with a single atomic bid. The induction step requires handling the two separate cases, OR and exclusive OR, to represent the OR of several OR star bids as a single OR star bid. We simply merge the set of clauses of the different OR star bids. To represent the exclusive OR of several OR star bids as a single OR star bid, we introduce a new dummy item, XST, for each pair of atomic bids, SV and TV prime, that are in two different original OR star bids. For each bid SV in any of the original OR star bids, we add to the generated OR star bid an atomic bid. The set S union the set XST such that T and V, where T ranges over all atomic bits in all of the other original OR star bits. It is clear that the inductive construction constructs an OR star bit with exactly S clauses in it, where S is the number of clauses in the original or exclusive OR formula. The number of dummy items in it however, may be large. However, we can remove most of these dummy items. One can see that the only significance of a dummy item in an OR bit is to disallow some 2 or more atomic bits to be taken concurrently. Thus, we may replace all the existing dummy items with at most just 2 new dummy items, one for each pair of atomic bits that cannot be taken together, according to the current set of dummy items. This dummy item will be added to both of the atomic bits in this pair. This simulation can be directly turned into a compiler that translates OR, exclusive OR formulae into OR bits. This has an extremely appealing implication for allocation algorithms. To any winner determination allocation algorithm, an OR bit looks just like a regular OR bit on a larger set of items. But an OR bit looks to an allocation algorithm just like a collection of atomic bits from different players. It follows that any allocation algorithm that can handle single-minded bits, i.e. atomic bits, can immediately also handle general valuations represented as OR bits or as general or exclusive OR formulae. In particular, the various heuristics mentioned in section 11.2 can all be applied for general valuations represented in these languages.